Okay, this is notes page for absolute value equations. So the definition of absolute value. The absolute value of any real number is the distance between the number and 0. So if we have this number line and here's 0, and we want to look at the number 2 and the number -2, 2 is 2 units away from 0. -2 is also 2 units away from 0. So the absolute value of x equals 2 means that x could be 2 or x could be -2. So that's what this is saying. So absolute value always has a positive condition and a negative condition. The numbers to the right of 0, the numbers to the left of 0 show you that. So why does that definition mean that absolute value functions do not have an inverse? Well, a function is a y equals absolute value of x. And so if we just say, let's say that again we wanted to pick ordered pairs, if we let x be 2, then y is 2. If we let x be -2, then y is 2. And remember, inverses, they have to be one-to-one functions. And a one-to-one function, the y's are different. And so with this one little example there, you can see that this y coordinate of 2 has a 2 and a -2 x coordinate. So, and then also, if you remember what absolute value functions look like, they look like v's. The absolute value, y equals absolute value of x would be when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. And it's going to be this line y equals x. But when x is -1, y is turning positive. Y is 1. When x is -2, the absolute value of -2 is +2. So you end up with this line here, y equals -x. So this fails the horizontal line test. So absolute value functions do not have inverses. But we're going to use this idea about the positive and negative condition to solve absolute value equations. So I have here some steps. First thing you want to do when you're solving an absolute value equation is isolate the absolute value expression. So the definition of absolute value, you can't apply it until it's all alone. So if we see something like this, absolute value of 2/3 x plus 3 plus 4 equals 10. This plus 4 is outside the absolute value, so we want to move it to the other side by doing the opposite of addition, which is subtraction. And that's what we mean by isolating the absolute value. Now that it's all alone on the left, you can apply the definition. It looks complicated here, but this is saying that the absolute value of x equals k, then that means that this x is equal to k, or this x is equal to -k. So what we're going to do is we're going to analyze this absolute value. We know that what's inside this absolute value might equal 6, but what's inside this absolute value might also equal -6. Okay, so I call this the positive condition, and this is the negative condition. Some things that people do wrong when they don't understand why we're doing what we're doing, they'll change this plus to a minus here. We're not changing the inside, the absolute value. We're saying that this might be 6, or it might be -6, because the absolute value of -6 is 6. So don't change the inside. Alright, so it says rewrite the absolute value equation as two separate equations. Equation 1, write the equation as is without the absolute value bars. Equation 2, write the equation with the absolute value symbols removed and the answer negated. Step 3, you solve each equation separately. So we want to get x by itself. So this plus 3 is what we want to get rid of first. Alright, so we're going to subtract 3, and that's 2/3 x is equal to 3. Now this 2/3 is being multiplied to x. So you might think, well, let's divide by 2/3, but it's a good idea to learn this trick. Your job is to get a 1 here. So if you multiply by 3/2, that's going to work. That's going to give you x. So remember that when you're multiplying by a fraction, if you multiply both sides by the reciprocal, that's a good idea. So 2/3 x, we want to get rid of 2/3 by multiplying by 3/2. Whatever we do to one side, we do the other. And then 3, you can make a fraction by 3/1. And I said in another video, multiplying by fractions is easier than adding. You just multiply straight across. So 3 times 3 is 9. Over 1 times 2 is 2. That's an improper fraction. Just leave it that way. Alright, now we got to come over and solve the other side. So I'm going to subtract 3. They cancel. That's 2/3 x equals -6 plus a -3. The signs are the same, so that's -9. You want to get x by itself or an understood 1 here, so multiplying by the reciprocal of 2/3 on this side gets rid of that fraction, and whatever you do to one side, do the other. So you get x equals -27/2. So those are both valid answers. If you want to check your work, you put the 9/2 in here. You get 3 plus 3 is 6. 6 plus 4 is 10. If you put -27/2 in here, you get -9 plus 3, which is -6. The absolute value of -6 is 6. 6 plus 4 is 10. So they both work. Alright, so let's do another one. So step 1, isolate the absolute value. Okay, so that means this is my absolute value. There's a 3 being multiplied to the absolute value, and there's a -4 outside the absolute value. So two things you have to know. You can't distribute into an absolute value. That's going to mess up your answer. You want to isolate the absolute value. So you need to know how to get rid of this -4 and get rid of this 3, and you need to know what order to do that. So you want to get rid of the term that's farthest away from this absolute value on this side. So we want to undo this -4 first by adding 4. Okay, and that's going to leave us with 3 times 1/2 x minus 5 equals 0. Now, to get rid of this 3 times, we're going to divide. The opposite of multiplication is division. So if we divide, we get absolute value of 1/2 x minus 5 is equal to 0. Okay, so we've done step 2. Now, after we have step 1, now that we have the absolute value isolated, we want to rewrite the absolute value as 2 equations. So the first one, you just lose the absolute value and you set it equal to 0. And the second one, you lose the absolute value and you set it to the opposite of 0. Well, 0 is neither negative nor positive. So in this case, you do not have to have 2 equations. So all we have to do is solve this one. So I'm going to add 5 to both sides. And that's 1/2 x equals 5. And again, if you're multiplying by a fraction, it's better to multiply by the reciprocal of that fraction and understand that that's going to get x by itself. Okay, so that gives you x equals 10, and that's the only answer. If we check our work, we put 10 in here. 1/2 times 10 is 5. 5 minus 5 is 0. 0, absolute value of 0 is 0, times 3 is 0. 0 minus 4 is -4. So that checks out. Okay, next example, example 3, we got a little bit more going on here. We have a quadratic, and I'll keep sliding in the quadratic so we can remember how to solve them. But it's an absolute value equation. So you have to look at that and say, oh, I have an absolute value equation. And so step 1, I have to isolate the absolute value. Well, if you look, it's already isolated. There's nothing else on the outside of it. So that step is done. Okay. The next step is to rewrite the absolute value as two equations. Equation 1 I call my positive condition, which means you take it out of the absolute value and just set it equal to 7. And the negative condition, you take it out of the absolute value and make it equal to -7. So now this is a quadratic equation. And so we have to know how to solve this. We have to not think about it like the other problems that we just did. If you're thinking that we need to add 5 to both sides, you have got to listen up. This is a quadratic, this x squared. You have to look at it and say, oh, we solved that a different way. That's a quadratic. The way you solve a quadratic is you set the quadratic equal to 0. So you have to go do something different than you're probably got comfortable with, and you need to subtract 7 from both sides because you want this quadratic, this will be -12, you want the quadratic equal to 0. 100% of the time you're going to set a quadratic equal to 0 to solve it. Okay, so you set it equal to 0, and then we have to factor it. And so I have a video on how to factor. This is what we call an easy one because it's just an x squared. So if this factors, it's going to factor into two binomials, and I know x and x go there. So all I have to do is check the factors of 12. 1 times 12, 2 times 6, 3 times 4. Okay, and then I want to see which of these subtract to be 4. And that would be 6 and 2. And I do the sign at the very end. I want these to subtract to be a -4. So that means I need a -6 and a +2. Alright, after you set it equal to 0, and after you factor, then you're going to set each factor equal to 0. And I went a little too fast there. Okay, so x equals 6 or x equals -2. So there's two answers on this side. Alright, then we have to do the same thing over here. We have another quadratic equation to solve. Okay, so what are you going to do? It's a quadratic. We have different types of equations now. We have to do different things. So we're not going to add 5. That won't work. You have to set it equal to 0. So I'm going to add 7 to both sides. That's x squared minus 4x plus 2 equals 0. Okay, and now we're going to try to factor it. Now if this factors, it's going to factor into two binomials, and x goes here and x goes here, and the factors of 2 are just 1 and 2. Now we have a problem because they need to add to be 4, and they don't. So there is another way to solve a quadratic. You may have heard of it. We're going to concentrate on it more, but it's called the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And if the quadratic is set equal to 0, the a is the coefficient in front of the x squared, the b is the coefficient in front of the x, and the c is the constant. So x equals -b, which would be +4 since b is -4, plus or minus -4, when you square it, is a +16. Always. Any kind of negative number squared is positive. -4 times 1 times 2. All of that, all over 2 times 1. So that gives me x equals 4 plus or minus 16 minus 8 is 8. Gives me 4 plus or minus square root of 8 is the same thing as 4 times 2, but let me show you what else this calculator will do. It will simplify radicals for you. So square root of 8 simplifies to 2 root 2. Now this is a grouping symbol, so remember that this 2 belongs to both terms. So this simplifies to 2 plus or minus square root of 2, because 4 divided by 2 is 2. 2 root 2 divided by 2 is 1. So what does this mean? Well, this means that we got 2 plus root 2, 2 minus root 2. So this problem right here actually has 4 solutions. And these are exact answers, and that's what we want. But 2 plus the square root of 2 is, hit the squiggle, approximately 3.41, and 2 minus the square root of 2 is approximately 0.56. And I don't want you to give me the decimals, but I do want to show you what's going on with this one. Okay, so just to show you what's going on with this one, I'm going to put in the left side of the absolute value as a function. Y equals, see if I can get this to work, y equals ABS parentheses. That's how you type in absolute value. X squared minus 4x minus 5. Okay, so you can see what the function y equals absolute value of x squared minus 4x minus 5. What's happening is absolute value makes everything positive. So this part right here, which wants to be a parabola, it got flipped over the x-axis, so it's positive. And then if I want to put in the right hand side, y equals 7, turns out that the intersection of these two lines is the solution. And I just want to confirm, see, we have x is 6, alright, x is negative 2, and then I think I wrote this down wrong. Yeah, this was 0.586 just to confirm it, and this was 3.41. So it did work out. There were actually 4 solutions there. It's really hard to make these up, so that's why the answers were kind of nasty, but still worth looking at. Okay, so that's a good way to check too. You can go to Desmos, and what I did again is I just put the left side in using ABS and the right side in, and I just looked at the intersection. Alright, let's look at example 4. This might be one you should be able to try. So again, step 1 is to isolate the absolute value. So you want to get rid of this negative 5, you want to get rid of this 3. The trick is you have to know who to get rid of first. And so you want to, this is one term and that's another term. We want to get rid of this plus 3 first. Right, so we're going to subtract 3 from both sides and get negative 5 times the absolute value is equal to negative 2. Then we need to get rid of this negative 5 that's being multiplied. Can't distribute it, but we want to undo multiplication by division. And that's going to give us absolute value of 2/3 x plus 4 equals 2/5. Don't worry about the fraction. The algebra doesn't change. And we have a calculator to help us with any kind of arithmetic. So we've isolated the absolute value. Step 2 is to rewrite this into 2 equations. I call it a positive condition and a negative condition. So I'm going to take it out of the absolute value. 2/3 x plus 4 equals positive 2/5, or 2/3 x plus 4, don't change that sign, equals a negative 2/5. Okay, so this is a good example because we need to get over our fear of fractions. We have a calculator. What's the algebra tell you to do? Alright, you're going to subtract 4 from both sides. Alright, that's going to give you 2/3 x is equal to. And instead of getting a common denominator, look, just use your calculator. What is 2/5 minus 4? And I would not put 3, personally I would rather put the fraction down. That's negative 18/5. Okay, and then to get rid of 2/3 times x, you can multiply by the reciprocal. Okay, and you can use your calculator, but I'm going to do some cross canceling just to sort of teach you this. 2 and 18, 9 goes into both of those, so 2 goes into both of those. So 2 goes into 2 once, 2 goes into negative 18, negative 9 times, so that's negative 27/5. Okay, you can use your calculator, so negative 18/5 times 3/2. Hit math, hit the squiggle, I mean. There you go. Alright, so do the algebra, let the calculator do the arithmetic if you're a little shaky on that. So I'm going to subtract 4 from both sides, get 2/3 x is equal to negative 2/5 minus 4. 22/5. Then I multiply both sides by 3/2. That's what the algebra tells me to do. And then the arithmetic, multiply this times 3/2 and negative 33/5. My answer. So I have two answers there. If you wanted to check your work, you could put it in here, use your calculator and see. It's got, let's see if I can remember, -5 math, there you go, and then go over to number and you'll find ABS on number 1, and then you can type in 2/3 times negative 27/5 plus 4. That's it for the absolute value. Then plus 3, when I hit enter it should equal 1, and it did. So that checks out. The other one would check out too. Alright, here we go with another one. It's a quadratic, but don't let that bother you yet. It's an absolute value. So how do you solve an absolute value? Well, step 1, you have to isolate the absolute value, and it's already isolated. And then step 2, you need to write two equations. I say positive and negative condition. So x squared minus 2x equals 8. X squared minus 2x equals negative 8. Do you recognize what kind of equation that is? It's not a linear one, it's a quadratic equation. So you have to set it equal to 0. So that's x squared minus 2x. If I subtract 8, like that, and that's a quadratic, and the way you solve a quadratic is you try to factor it. The factors of 8, 1 and 8, 2 and 4, that subtract to be 2 are 4 and 2, and I want the 4 to be negative and the 2 to be positive. So setting each of these factors equal to 0, I get x is 4, or x is negative 2. Okay, this one, again, it's quadratic, so the way you solve that is you want to set it equal to 0. So that's going to give me x squared minus 2x plus 8 equals 0. I have another problem there, but let's go through it. We have to try to factor it. Factors of 8, 1 and 8, 2 and 4, that add up to be negative 2. It don't work, doesn't factor. So let's try the quadratic formula. X equals 2, negative b, so opposite of b is 2, plus or minus b squared, which would be always a positive number. Negative 2 quantity squared is 4, minus 4 times a times c, all over 2. We're getting a little bit ahead of ourselves, but sometimes it's okay. So 4 minus 32 is a negative 28. And remember, it's good to have this happen because we have to understand why we learn about domain at the beginning of the semester. Remember, you're not allowed to have a negative under a radical. That's not a real number. Now, it's an imaginary number, but we're not, when we're solving, we're trying to find real number solutions unless I tell you, which I will explain. So for right now, if you were to get this, it just means that there are no real number solutions for this one. So let's look at desmos. Okay, so let's see. Here we go. So y equals, on the left side, ABS x squared, hit the right arrow key, minus 2x, close the parentheses. And then on the right we have y equals 8. And y, that is not showing up because my graph's over there. Now if I look at the intersection, see, I just have one. X is negative 2 and x is 4. So that's why this one didn't come out to be a solution, because there's only two solutions there. Okay, so let's go to the lab manual. If you go to page 46, but if you look at the table of contents, look for absolute value equations, and just there's a couple here that we probably need to look at. This one I'm not going to do, but you would want to get rid of this division by 4, so you would want to multiply both sides by 4 to isolate your absolute value. This is what I want to look at, because this is a common error right here. See that -8, -8 minus 3, you know what a lot of people do is they'll make that -11. Okay, so you wouldn't do that because we never forget PEMDAS. And PEMDAS says that you have to multiply before you add or subtract. So this is -3 times the absolute value. So you cannot add the -8 minus 3. That's a violation of PEMDAS. What you have to do is isolate the absolute value. So the first thing, you want to get rid of the thing that's farthest away from this expression as the absolute value, and that's the -8. So you would want to add 8 to both sides. That's going to leave you with -3 times the absolute value of x minus 1 equals -24. And then you want to divide by -3 because we have to isolate the absolute value. And this is actually good news. We have a negative divided by negative is a +8. Do you know you have to have an absolute value equal to a positive number by the definition of absolute value? It's the distance a number is from 0. So this can't equal a negative number. So that means we can keep going. So x minus 1 equals 8. Or x minus 1 equals -8. So if we add 1, we get x is 9. Here, if we add 1, we get x is -7. So that's common error there. All right, and then the last one I want to go over, I may have given it away just now talking about this. It says the equation absolute value of x equals -2 has no solution. Explain why. Well, by definition of absolute value, it's the distance a number is from 0, and distance can't be negative. Absolute value is defined to always just be a positive number. So there's nothing, your job is to solve for x, right? There is no number that you can put in for x that will make this a true statement. That's what it means to solve. Find what values of x make a true statement. You can't put 2 in there. The absolute value of 2 is 2, not -2. You can't put -2 in there. The absolute value of -2 is 2, not -2. So if you ever end up with an absolute value equals a negative number, then all you have to do is just say, oh, there is no solution. There is no x value in the universe that would ever make that true.